So let's do exercise number 2. I've got photo gates set up right at the top of the track. We're going to do a 2-gate mode. This is something similar to what we did before in the previous lab. I've got 2 photo tapes taped together so I can get my best estimate of the velocity at that single point in time. It is still an estimate because it's not instantaneous. It's still an average velocity. So if you remember from before what the distance between the photo gates were, you can see the thing, it's from one eye to another, it's 1.5 centimeters. So the distance that we're going to time the ball is 1.5 centimeters, or 0.015 meters. So we're going to get an average time. We're going to take the distance, 0.015 centimeters, divide by the time, which is the average time we're going to take for 5 trials. And then your 0.015 meters divided by the average time, and you get your velocity in meters per second. You're going to compare that with the theoretical value that, using the radius of the loop in exercise 3. So let's start off. I'm going to zero my timer, and let's take our first reading. I've got the height marked off that we figured out in exercise number 1. And see that at the moment at the top of the loop, it's just losing contact. 0.0139, 0.0139 is the first reading. So let's do a few of them. I reset the timer. Everything else is all the same. Okay, so this one is 0.0147. 0.0147. Okay, we reset. Point 0.0145. 0.0145. Reset the timer, go back up here, release the ball. Release the Kraken. 0.0148. 0.0148. And the last measurement, gotta reset the timer first, is 0.0148. 0.0148. And yes, I did reset it. You heard me reset it. Just happens to be exactly the same. So take the average of the times. The distance between the 2 photo gates is the distance it's timing it. So distance divided by the average time, and you will get your experimental value of the critical velocity. And in the next exercise, all you have to do is plug in. I don't have to make a video of it. And then you can compare this experimental value with the value you get from the formula.